Today, I'm so excited to share with you my conversation with Dr. Dan Yarosh. Dr. Yarosh was on my channel 4 years ago, and it was one of the most impactful videos I've done for YouTube. It was probably the most impactful conversation I had about skincare and the skincare that I use on my own skin, the skincare that I recommend to you, and it really has a lot to do with the health of our skin and skin cancer. So Dr. Yarosh is a PhD in molecular biology. He has served as a fellow and an expert at the Cancer Institute. He has studied and pioneered DNA repair enzymes since the beginning. He will explain how they actually work, how a skincare product can actually help your DNA be repaired in your skin. I think you will get a greater understanding for why I talk so much about DNA repair enzymes, because it's not just a fascinating subject when it comes to the aesthetic of our skin. It is more than that. It is all about skin cancer regression, preventing skin cancer, and the general health of our skin. And with that comes the aesthetic stuff. With that comes the improvement in our collagen and our elastin, and then ultimately fine lines and wrinkles and age spots, etc. I asked him about DNA repair enzymes and microneedling because that is something that I am personally doing. Super excited to share that with you in my microneedling content. I do want to say I recorded this over Zoom. I'm recording the intro with my normal camera, but I recorded this over Zoom, and both of at least my image is definitely kind of whitewashed out and looks, I don't know, almost creamy. So please forgive that because it's literally recorded on my little laptop sitting right here. So it's not the normal clarity or anything like that. So please forgive that. The information is golden. It's golden. Doesn't matter that it's over Zoom. So let's go. For those who may not be familiar, could you share a bit about your role in developing the first DNA repair enzyme technologies for topical use? Basically, give us a little bit of a history about you and DNA repair enzymes way back when.
Yeah, well, way back when we wanted to study DNA repair, we had to make our own enzymes. You couldn't go to the store and buy them or order them in a catalog. And so part of my training was learning how to purify DNA repair enzymes from bacteria and other sources so we could use them as tools. And it's a long process. And while I'm doing this, I'm saying these have got to be useful for something else other than just doing science. And so there was always in the back of my mind the idea that we ought to put these enzymes to use. And then there was a study that was done by Japanese scientists who showed you could take an enzyme from bacteria and put it into human cells and they would work. Now, this was revolutionary, the idea that you could cross species, let alone cross from bacteria to humans. And so now I started to think, okay, now we have a tool that we can really use, but how to get it into cells. And that's when I began to study liposomes as a way of delivery into skin. So it took these two concepts, purifying enzymes that were tools and liposomes as a delivery vehicle, put them together. Now you have everything you need to try to change the skin.
So can you explain what a liposome is?
Sure. So, living cells are encased in a membrane, a lipid membrane that's very flexible and it allows things to come in and come out. And so a liposome is just that membrane made into a ball. And if you do it in the right way, you can encapsulate things inside. When you're making the ball, you can have enzymes inside when it forms. And so what we did is choose lipids to make the membrane that are very similar to the lipids of the skin. And so these liposomes to the skin look like other sister cells. And so they're able to take them into the skin. They know how to process them because they look like other skin cells. And we added one little trick, which is we taught the liposome when to open up and release it by having a chemical trigger in the lipid membrane. So it's stable on the outside of the cell, but when it gets into the inside of the cell, the pH changes and the liposome opens up. And we actually have electron micrograph pictures, microscopic pictures of liposomes opening up, blowing up inside of cells. That was one of the great collaborations and so exciting when the first time I saw that picture.
So now we're going to get into kind of some foundational concepts, I think, for people who are new to this, and even for people who are veterans in DNA repair. For those new to the concept, what are DNA repair enzymes? We're going to go basic, and why are they important in skincare?
Right. Well, so DNA repair enzymes, very simple. They're proteins, and the whole body is made up of lipids and proteins and nucleic acids, but proteins are the same thing that's in meat. It's just these proteins do chemical work. They're catalysts. They bring together two molecules and make them do chemistry, whereas if you were relying on these molecules floating around, they might or might not reach each other. But an enzyme catalyzes a chemical reaction by bringing two components in close together, and they do the chemistry faster than if they just relied on chance. And so DNA repair enzymes are enzymes that bind specifically to damaged DNA. They don't bind to anything else. They don't bind to sugar. They don't bind to actin, collagen. They bind to damaged DNA. And when they get there, they do chemistry that would take much, much longer if it wasn't for the enzyme there to speed up the reaction. So it speeds up a normal reaction. What we do by delivering DNA repair enzymes is make that reaction even faster. So we don't just rely on we say endogenous, the enzymes that are already present in skin. We add more to speed up even faster that reaction.
That's what I was going to ask you is we have obviously DNA repair enzymes. That is the natural process. And what we're doing in skincare or medicine, depending on what we're talking about, is adding more, like you said, to speed up the process.
Well, let me just say that the DNA repair enzymes speed up a normal reaction. Now, the normal reaction is relatively slow in skin. So if you get a sunburn, the next day, 24 hours later, you still have about 50% of the DNA damage still there. And then another day, it removes 25%. So we have a normal repair process, and that's good enough to hold off skin cancer for 50 or 60 years on average, some people worse. But eventually, the enzymes can't catch everything. So the goal is to speed up the normal rate, get rid of that damage, and get rid of all the signals. So yes, we have a DNA repair pathway. I should say we don't have a photolyase. So the photoreactivating enzyme that's found in some of the skincare products comes from sources other than human, because we don't have a photolyase. It turns out another fascinating part of the story is we have a gene that kind of looks like a photolyase, a gene for a photolyase, but it's been hijacked by our evolution and it's used for something else. So we gave up our photolyase, our photoreactivating enzyme, and we're very dependent on this other process that snips the DNA out. So some of the products speed up a normal process, but the photolyase is adding a new repair process that we don't ordinarily have.
I like to look for the photolyase along with the other DNA repair, because the way I look at it is I'm getting a little bit of extra help in the moment as the sun, as we're incurring the damage, but then you get the extra help with the repair, like overnight kind of thing. That's how I look at it, is like coming at it from two different directions and two different speeds too. Because my understanding is the photolyase is faster but only does 50%, if I remember from our last conversation, and the
Right.
others are slower, but they repair more. Is that right?
That's right. But there's one other aspect. The photolyase needs light.
Right.
So that's something you need to add during the day. It can be reactivated by a room light. It's slower than if you go outside and get sunlight, but it'll work in room light, but it can't work at night when you turn the lights out. The other enzymes can work at night. They're not dependent on the light.
Next question is, how does DNA damage from UV exposure actually lead to photoaging and skin cancer over time?
So this is a process of wounding and healing and wounding and healing. So you're constantly exposed to environmental damage, particularly sun damage. And the estimate is about every cell in your skin incurs 10,000 sites of damage every day. Every cell has to deal with 10,000 sites of damage. So you're constantly doing this repair process. And as I said, it's very efficient. But over time, you have damage and then repair and then damage and repair, wounding and healing. The healing's never 100%. And so the fewer rounds of wounding and healing is always better. So the accumulation over time of imperfect repair you see as a wrinkle, where the collagen has been fixed but not quite good enough. And you see pigmentation changes where the pigment is activated and it doesn't really go away, it stays there. So it's this cycle of wounding and healing that eventually leads to the signs of photoaging, even when you have good repair.
Why are traditional sunscreens not enough? What is the gap that DNA repair enzymes might help fill when, sunscreen isn't enough to prevent what we were just talking about?
Yeah, exactly right. Well, so sunscreens are great and people should use them, but they're not perfect. The first point is they do let in light. There's no sunscreen that's perfect that absorbs all the damaging wavelengths of light. And particularly, people want sunscreens that make their skin look good. The second thing is human nature. People don't apply sunscreens as much as doctors would like them to apply. And in fact, studies have been done that show we only put on about 50% of the amount of sunscreen that's used when you get a number like SPF 50. So the SPF test is very specific, and it puts on a huge amount of sunscreen and you get a number. And then people say, oh, great, I have a SPF 50. But in practice, when they look at how people use it, they're probably only getting an SPF of 25. And so if you use a 30, you're probably only getting a 15. So it's just a matter of human nature. And the third thing that makes DNA repair enzymes an advantage is you can use it after sun exposure. So sunscreens don't do you any good if you put them on after you've been out in the sun. But if you apply DNA repair enzymes after sun exposure, you can still repair the damage before you begin that wounding and healing cycle.
Can you explain how bacterial or plant-based enzymes can function effectively in human skin cells?
This was one of the most amazing findings of science, but it goes back to the point of enzymes that all they know is to recognize DNA. And DNA is DNA is DNA. The same DNA in a bacteria is in human cells. We just have a different code. And so it turns out that enzymes in bacteria that are built to repair bacterial DNA can also recognize the same damage in human DNA. And so they can speed up the same repair process in humans as they do in bacteria. So this was one of the most startling observations, that the cross-species specificity of enzymes. So you can take enzymes from bacterial sources, and now there's a lot of fermentation, so you don't even have to, they're done in a biotechnology way, and in fact, it's a big advantage. They're sustainable, less resources are used to make them, but you can make a vat of enzymes and use them to apply to skin rather than having to go get the human source of enzyme.
Right.
So this was really a startling finding, but probably consistent with our idea that it's DNA damaged no matter where it is, and almost every organism on Earth has a DNA repair system.
How are DNA repair enzymes delivered into the skin, and do they actually reach the cells where the damage occurs?
Well, this was the big hurdle. It's one thing to have a tool, but getting it in the right place was the big challenge. And so we spent several years looking for delivery systems. And remember, it's not enough to get it into skin. The skin still has to be healthy afterwards. So there are various things called penetration enhancers, but they generally damage the skin. So that's when we started looking at liposomes, because they're gentle and they have this mechanism of being taken up by the skin cells because they're recognized as sister cells. So this was really the breakthrough, and was our first patent was on engineering liposomes to encapsulate the enzyme, which is hard enough, but not as difficult as finding the right lipid composition that would encapsulate the enzyme, get into the skin, and then be taken up by skin cells. And not surprisingly, the composition of that liposome is very similar to the lipid membrane of skin cells.
So interestingly, I do a lot of microneedling. Microneedling when I was in the clinic was probably my most, the treatment that I performed the most. And it's one of the things that I consider myself relatively expert in. And I just started doing a new kind of protocol for myself. And I started incorporating DNA repair enzymes into my microneedling. And I don't know why it's working, but my goodness. I mean, obviously there's lots of, I have lots of theories, but absolutely incredible to combine those two modalities. Have you heard of that at all?
Oh, it makes perfect sense. That this is the limiting factor in the use of these enzymes, is getting them into skin in the right place at the right time. So here you're delivering them immediately. So right, microneedling, has this balance between, you want to poke a hole, but you don't want to do damage. So
Right.
the length of the needle and the composition of the needle are all very, very important, just like engineering the liposome.
Right.
But things that can deliver repair enzymes into skin at the right time are all going to have the same beneficial, or going to have very similar beneficial effects. But you still need to get the enzyme into the cell. So
Right.
you still need the liposome delivery, even if you're using a microneedle.
When is the best time to use a product with DNA repair enzymes, morning or night?
Well, that depends on which enzyme. We talked a little bit about you need light to activate the photoreactivating enzyme. So if the product has, I guess the cosmetic term is plankton extract, is what you would see on the label for a photoreactivating enzyme, a photolyase, then it should be used in the morning. Because that's when you're going out and getting light exposure. Now, you can use it late in the day, but it requires light exposure, so it should be used earlier so that you get the most benefit from it. The other enzymes that are used, Micrococcus Lysate or OGG1, which repair UV damage and oxidation damage, they don't require light activation, so they can be used at night, and they'll work at night. And in fact, the normal DNA repair process in human skin sort of is quiet during the day and then picks up late in the afternoon and works at night. And this is probably controlled by the circadian rhythm. And if you stop and think about it, it makes good sense. If you've ever worked late in the office and the cleaning crew came in and you're trying to type and they're trying to vacuum underneath, it's a mess. The whole idea is you work during the day and you let the cleanup crew come in at night. And that's the same thing with skin. You're functioning, you're outside, you're perspiring, you're UV exposure, you're doing everything. And that's when the repair processes are quiet. And then when you go to sleep, then the normal metabolic processes calm down and the repair processes take over and get their work done at night. So that's why the micrococcus and the OGG1, the Arabidopsis extract, are best used later in the day, so they're in sync with the normal repair process. But the photolyase works like that.
Okay, next question. Can you layer DNA repair enzymes with retinoids, antioxidants, exfoliants, etc.?
Yeah, there's nothing about any of those that interact that we know of, since the liposome shields the enzymes from other things.
I tend to do, in my morning routine, I will do an exfoliant like in a toner form, but then I wait quite a long time. I mean, I'm confident that my skin has, because it'll reset itself before I go on, because I do use a product with a photolyase and actually all 3 DNA repair enzymes. And I love to combine my photolyase product with LED, because I just figured I might as well light a fire.
Well, that's
trying to, how can I play around, and so I like to do that, even though I know that it doesn't require that, but especially used during the day, obviously. But I'm always kind of playing around with the combination of the things. This is a question I get a lot, and I just would love to have your take on it. And it's, how long does someone need to use these products before they see visible results?
Yeah. Well, that's what people are looking for. So if you need to have if you're going to a party that night and you're putting on DNA repair enzymes in the morning thinking you're going to be ready for the party, it's probably not going to work. That's why we have makeup. But the point of DNA repair enzymes is to make skin healthier. And people are very good at spotting healthy skin. So when we can take pictures and see differences in a week, in 2 weeks, from repairing damage and changes in evenness of skin tone we can measure, changes in small fine lines and wrinkles we can measure, but people notice healthy skin very early on. But it does take weeks, and when we've done clinical studies, we look 4 weeks, 6 weeks, 8 weeks later. So it's more than just appearance, it's going for that healthy skin. And you want to continue that. So there'll be a few days, a week, 2 weeks, you'll notice a difference, but then it's something you need to maintain in order to have all the benefits of enhanced DNA repair.
I like to tell people too that a lot of times, a lot of my audience is 50 and older. And it's if you're just starting on a reparative skin regimen, we have years to, it's not going to happen overnight. And a normal skin cycle at that age is usually 5 weeks or more, and so we're trying to heal this broken situation underneath, and it's got to ever expose itself before you're going to see, whereas I feel like it's exactly what you said. You can spot healthy skin, and maybe to the person who's being overly critical of themselves, that one age spot isn't gone in 3 weeks, but their skin is overall healthier and looking better. And you just have to keep consistency. Would you agree?
Yes, and Penn, I would tell you what I tell people who ask me that similar question. I said, okay, fine, take a picture of yourself now and then start using the product because the changes are slow. And someone will say after a week, oh, I don't really notice anything. Well, take a look at this picture, take a look at this picture, and people are surprised because they only remember how they looked the last time they looked in the mirror. So I recommend to people, no matter what product they're going to try, take a picture of yourself.
Picture. That is probably some of the best advice. And I agree with any product that you start to take a picture so that you can have more of a realistic kind of perception.
Yeah, and people tend to focus on the one blemish.
Sure.
And they say, my one blemish hasn't gone away. Well, look at the rest of your face. Yes. Everyone's saying you look healthy.
Is there an ideal age to start using DNA repair enzymes, or is it ever too late to benefit from them?
No, I think there was a perception that you get most of your sun exposure when you're a kid, and so whatever damage was done is done, and there's nothing you can do about it. And that turns out not to be true. We continually get sun exposure. And so there's not a point at which it's baked in and you can't do anything about it. And it's really never too young. You have DNA damage. As I said, in emergencies, you need to repair DNA damage. So children can use these products. I, in general, don't encourage preteens and teenagers to use anything more than moisturizers and sunscreen because their skin is healthy and heals itself, and you don't want to mess with that.
Yeah.
But I think the bigger problem is people that are fatalistic and say whatever's going to happen has happened. I can't do anything about it. And that's what modern research has shown, that we have this constant healing process. And the other thing that I think we'll touch on more is your immune system. So one of the remarkable findings is that sun damage also impairs your immune system, and it actually allows cancers to grow out. And so even if you've had damage in the past, your body can suppress it. But if you in turn suppress the immune system, it then releases the floodgates and past damage can occur. So that's why it's so important that people understand it's never too late, that you need a healthy immune system in a healthy skin in order to maintain your appearance and good health. When you have damage in your DNA, you've got maybe a week to get rid of it. And eventually, the cell is going to call upon that part of DNA either to divide or to code for information for it to operate. And then it's got to handle it one way or another. In some instances, the cell just, it's called apoptosis, the cell just dies. Terrible, but it's getting rid of the problem, and you slough it off. But in some cases, that damage isn't repaired and it becomes a mutation. And so our skin is filled with cells that have mutations, but we have a way of keeping that in check, which is our immune system. So if a cell like that starts to grow, the immune system comes in and repairs it. So what's in your skin from past damage is not necessarily the DNA damage, but it's the cell that's now changed, and it's sort of waiting for an opportunity to go crazy. And you have systems in your skin to keep those damaged cells from getting out of control. And what continued UV exposure does is weaken the immune system and allow these precancers, age spots, dysfunctional cells to grow out. And that's kind of where you go with the longevity and the senescence story. Yeah. Is what are these cells doing while they're laying there? But I think the understanding that the immune system is suppressed by sun exposure is critical to understanding what happens to our skin.
So since we talked about it a little bit, let's talk about senescence. That is something that we've talked about in my community a bunch, the zombie cells and what that means. Explain what DNA repair enzymes are now in relation to senescent cells.
Right. So senescent cells are cells that follow one of several pathways. So when cells are damaged, they can do several things can happen to them. One is they get completely repaired and they're back to normal. They're out of the hospital and they're back on the front lines doing what they're supposed to do. The second pathway is what I explained. When damage is too great, the cell says, I can't fix this. I'm committing suicide. I go into an apoptotic pathway and it dies and it gets sloughed off. And of course, if you've ever had a sunburn and your skin peels, that's just a whole sheet of cells which have committed suicide and said, too much damage, can't be fixed, we're out of here. But there's another pathway that happens when a cell's not damaged enough to kill itself, but it's still not functioning properly. And it goes into a pathway that we call senescence. And some people refer to it as the zombie cell. And that's because it doesn't function like a normal cell. It stops dividing, which is, of course, for a skin cell, that's the purpose, is to divide and form the outer layer. So it stops dividing, and in addition, it sends out damaging signals. It's the signals that the senescent cells send out that cause it to be so dangerous. It sends out inflammatory signals, and so you have these little micro regions in the skin of inflammation, and it sends out cells to dilate blood vessels. So you get that spider vein look in damaged skin, and the skin gets thinner because the cells aren't dividing, so you can see through it, and the skin doesn't look quite as healthy. So these senescent cells are not alive, but they're not dead, but they contain DNA damage. And so a way to deal with them is to improve their DNA repair and get them to remove the damage, change the functioning so that they stop sending out these inflammatory signals, or to help the cells around them get rid of them. You're senescent, you've got to get out of here. And studies have used a new category of compounds that are called senolytics, which means they lyse senescent cells. It's a very hot topic of research now, looking for compounds that make senescent cells die, and when tissue gets rid of the senescent cells, the tissue is much healthier. So this is the big emphasis on longevity right now. It's not so much trying to live longer, it's living healthier longer.
Yes.
And you can do that by getting rid of these zombie senescent cells.
So the DNA repair enzymes are never going to take a senescent cell and make it back into a normal cell. It's going to enable your body, hopefully, to get rid of that cell.
Right, and it takes away the damaged signals of one of the characteristics of senescence is all these signals to bring in inflammatory cells, produce hydrogen peroxide, to dilate blood vessels. So it calms down the signaling and gives the skin a chance to get rid of that cell, which is really what has to happen to senescent cells.
And, that's so interesting to me too, because I remember when I was first studying senescence, when it's in regards to skin, and they were talking about the soup because of all of the senescent cells. Like when they get together, it gets even worse. It's like a rotting bucket of apples kind of thing.
Yes.
And so the idea of even getting rid of some of them is going to improve the situation because of all of the, in aggregate, it's even more of those signals and inflammation and all of that stuff. I have to say, I already love DNA repair enzymes. I already, but this is one of those things where you're like, you got to be kidding. It's like, it's so neat, that's such what a side benefit. It's already doing all of these other things. It's also helping with senescence, which is pretty incredible. And I would agree, it's a hot topic right now. I mean, it's a big topic in my community and also in regards to other things besides skin, obviously, but in skin, it's a big deal in my community in particular. So that's really, really exciting. In clinical studies, we've seen reductions in actinic keratosis and even early skin cancers. Can you talk a little bit more about that?
Right. So part of this all relates to the immune system. So there's a pathway from a cell that gets damaged, then has a mutation, and then becomes an actinic keratosis, which is a precancer. It's a cell that started to divide, but it hasn't gone all the way to the cancer, the full cancer phenotype. But it's a cell that's out of control, and it has to be controlled. And the immune system is able to recognize an actinic keratosis as an unusual type of cell and attack it and destroy it. But if you have UV exposure to that area of skin, you suppress the immune system, and it allows that actinic keratosis to continue and to grow. And often from within that actinic keratosis, one of those cells takes the last step and becomes a skin cancer. And again, the immune system would be able to remove that skin cancer cell. But again, if it's suppressed, then that skin cancer can grow. So in studies using DNA repair enzymes, the first thing that was observed was a reduction in the appearance of new actinic keratoses and the regression of existing actinic keratoses to go away. So for most people, if they get an actinic keratosis, it's a little patchy part of the skin, bothers them for a little while. Usually it goes away. That's the immune system doing its job. But if you have suppression of the immune system, then it can grow out. And that's what DNA repair enzymes do. They help preserve the immune system. And we think that's why you see a regression of actinic keratosis and prevention of new cancers.
I think that is probably the coolest thing of all of the things. Since our first chat several years ago, I cannot tell you the number of people who have commented and said, I had a couple AKs that completely went away. I mean, like, I've heard that so many times that it isn't just some scientific, like, oh, this happens. I mean, I have so many testimonials from people, and I just think that it's pretty phenomenal. And I'm always telling the women in my community, make sure you get your lower legs, because women tend to get skin cancers on their lower legs. And I think, we're busy and we're not paying enough attention, and we're getting more UV in the summer while we're out with our kids and all of that. And we don't even realize that that is what's allowing those skin cancers to come forward that have been just sitting there waiting, for all these years. Anyway, I think that that's fascinating, and probably the number one reason to use DNA repair enzymes, in my opinion, is to help regress and prevent skin cancer.
Yeah, I agree with you. And this is also a trend in other aspects of medicine, arming the immune system to help. So you can have all these chemotherapeutic drugs, but if you have a strong immune system, and this whole category of checkpoint inhibitors, turning the immune system loose has become, I think, one of the biggest medical discoveries that we have within ourselves, our own best weapon.
Okay, this is just a personal. What surprised you most in the clinical research on these enzymes?
Finding the regression of the actinic keratoses. Our first clinical studies were designed only to look for new precancers and new cancers. And so we actually required that patients who entered the study had to have everything removed. They had to start out with clean skin. And we did the research, and over a year's period of time, we could measure a change in the appearance of new cancers. But then, just as you said, there were anecdotal reports that we were hearing from people who were using it in the safety studies, saying that their cancers regressed. And it turns out in some of the clinical studies, not all the precancers were removed. They did the best they could, but there were some things the patient noted. And then the patient said, look, this has gone away, and the doctors reported it back. So that was unexpected and quite surprising support for the idea of how powerful the immune system is. But that was the most surprising aspect of the clinical study.
I think people need to have reasonable expectations with all of this. As much as I think that this is so amazing and I sing it from the rooftops and stuff like that, it's still really important, I think, for people to manage expectations. So a lot of people think of dark spots or pigmentation as something that you need to treat directly, but DNA repair enzymes don't bleach or lighten the spot. Can you explain what actually is happening on a cellular level with when these enzymes are at work? And I know you have already done that, but one more time so that people understand that if they have a dark spot, DNA repair enzymes being applied isn't actually lightening that dark spot, correct?
Right. Right. So the DNA damage triggers cells to make more pigment. And that makes sense. If you're damaged, the first thing you want to do is put up an umbrella to stop it. And so DNA damage is a trigger to the melanocytes to make more melanin. That's the technical terms. It's for the pigment cells to make more pigment. That's a normal response. So by removing the DNA damage, you stop the signals that come from all the cells, not just melanocytes. All the sister cells are saying, do something, put up the umbrella. And so by getting rid of the DNA damage, you remove the signaling that causes melanocytes to make more pigment. It'll take time for the existing pigment to be removed, but you're treating the root cause, which is the hazard warning sign that goes up. I've been damaged, make more pigment. There are products that are designed to stop pigmentation, and what they do is inhibit the enzyme that makes pigment. Right. And they will work. They will stop the pigment from being made because they mess up the machinery, but they don't do anything to stop the signal and the stress response that leads to pigmentation. So as soon as you miss a day or stop, the pigmentation comes back. When you remove the DNA damage, you get at the root cause and you stop the signal.
Yes. And, it's interesting because I am somebody who's prone to hyperpigmentation. And my 1-2 punch is to use all those tyrosinase inhibitors and DNA repair enzymes, because I figure what the heck, and I'm just diligent with, and I always tell people those pigment inhibitors are like a guard. And if you let the guard off duty, that guard has to be there all the time. And it's exactly what you just said. If you let the guard off, the melanin is going to be back in action. But if you're using DNA repair enzymes at the same time, to me, that's like a 1-2 punch, because you're kind of treating the root and you're helping inhibit so that you might see those healthy cells come to the surface as you're getting rid of the old stuff as it slops off. I just appreciate you so much for coming back and talking to me. The discussion that we had 4 years ago seriously was probably one of the most impactful skincare discussions I've ever had, and has shaped my skincare research myself and everything for all these years. So it's an honor for you to be here. So I really, really appreciate it, and I hope that you are living your best life now in the sunshine. In the sunshine.
I know how to deal with it.
So you better be coating yourself.
I do. And I appreciate you very much. I think you have one of the best shows I've seen, and you take such great care to get it right and not just put out what everyone wants to hear, but you want to get the story right. And I appreciate the work that you put into it. So congratulations.
Thank you. That means so much to me. Yes. Okay, good. All right. Well, thank you. And I will talk to you again soon. Okay.
Thank you very much.
Bye.
Bye-bye.
All right, you guys, I hope you enjoyed that conversation with Dr. Yarosh. Please do leave any questions, any follow-up questions you might have down below. Please let Dr. Yarosh know in the comments that you appreciate that he would come out of retirement and come on this channel and do this with me, because I really genuinely appreciate that 4 years later, he's willing to come back and do another round of questions and answers for our audience. He's passionate about getting the message out about DNA repair enzymes, because they are, to me, one of our best tools in our skincare toolbox for skin health and skin aesthetics, as far as I'm concerned. All right, I hope you have a wonderful day, and I will talk to you in my next skincare video. Take care.